Right, what we'll do now is run through a chi-square test. So you use a chi-square test whenever you've got data when you're looking at frequencies this time. So you're not looking at scores on a dependent variable. You're looking at the distribution of particular frequencies in a data set. And what I've got here is data that's very similar to what you'll be doing in the practical. So this example here, they wanted to look at whether attendance at lectures had an impact on their exam performance in terms of just this time whether they passed or failed. So the attendance was coded as 1 for if students generally attended lectures barring illness, and 2 for if they hardly ever or never attended lectures. So are students who attend lectures more likely to pass an exam? Or conversely, are students who don't attend any lectures more likely to fail? So we'll go into running the chi-square now. The first thing you need to do, now in SPSS, you can have the data set up in 2 ways for a chi-square. You could list each data point in terms of each individual person's data for each of the rows. Also, SPSS allows you to summarize the data via the frequencies. So for this example, 84 students attended lectures and passed the exam. 29 students attended and failed. 22 students didn't attend and passed the exam, and 35 students didn't attend and failed. When you've got the data like this, what you need to do is just tell SPSS how to deal with this data. So if you go into the data option, and I've just realized it will be off my screen. So what you want to do is scroll down to the right at the bottom, just before the bottom, it'll say weight cases, and you want to click on that, which will bring up this box. And what you need to do is just tell SPSS that you want to weight the cases by this frequency variable here. So you can put that into there and click on OK. And then that will all be fine then. Right. And now you can run the chi-square. So what you need to do is go up to Analyze and go to Descriptive Statistics and go to Crosstabs and bring up this table. Now we can ignore this frequency variable now. That was just used to weight the data. So we can put attendance into the row and exam into the columns. It doesn't really matter which order they go in. We'll select some statistics. So we'll select the chi-square statistic, and we'll also select Kramer's V. That's the measure of effect size. Click on Continue for that. Now we'll just select some extra options. So go into Cells. You can select, if you wanted to, the expected counts. This will give you, so in a chi-square, it compares the observed data to the expected data. So you can select expected counts if you want. We'll just leave that off for the moment and focus on percentages for row, column, and total. Click on Continue, and then you can run now that chi-square by clicking on OK. Right, we'll have a look at the output now then. And what I did is selected all of the percentages that you can get up, and we'll just have a look at a few of these that are most important for this data. But before that, you can look at the counts for these. So we'll take the first line here. You can see that this is the line for people who attended lectures, and the counts are the number of people who passed the exam versus failed. So for this line, 84 people passed the exam and 29 people failed the exam when they attended lectures. You can also look at the next line, and this gives you the same information, but now in percentages. So we've got when people attended lectures, 74.3% of those passed the exam and 25.7% failed the exam. Now we'll go on to people who didn't attend lectures. The counts give you the overall numbers. So for people who didn't attend lectures, 22 of those passed and 35 failed. And again, you can look at the percentages. So now in percentage terms, when people that didn't attend lectures, 38.6% passed the exam, but 61.4% failed. And there's various other bits of information in that table you can look at as well. So you could look at, if you want to do the total counts, and this just gives you the proportion of people who passed the exam versus failed the exam overall, and also gives you the numbers. So you can work with the numbers or work with the percentages. Usually for interpretation, when you're just looking at that data, it's easier to use the percentages. But in the calculation for the odds ratio, we'll use the overall counts. Before we get onto that, we'll just look at the results from the chi-square test now. And this gives you if you look at the top row, this gives you the chi-square statistic, which is 20.617, the degrees of freedom, and whether this statistic was significant or not. So the p-value was less than 0.001. So you can just feed the information from this table. If you're writing this up, you'll see the degrees of freedom are 1. This will always be 1 in a 2x2 chi-square. The chi-square statistic is here, and the p-value of less than 0.001 is here. One thing that you will have covered in the lecture is that you need to check whether the assumption has been met that you've got expected counts more than 5. So if you've got expected counts of less than 5 in any cells, then this can be a problem for chi-square. But for this example, you can see that it's reported that 0 cells have expected counts less than 5. So we don't need to worry about that. We've met that assumption of a chi-square test. One thing that you can then look at is the Kramer's V effect size. This gives you an effect size measure that can be interpreted in the same way or a similar way as the correlation coefficient. So here we've got Kramer's V of 0.348. We'll round that up to 0.35, and that indicates a medium effect size. Quite often, though, what you'll want to follow this up with is calculation of an odds ratio, which gives you a more precise measure of exactly the relationship between these variables. And we calculate this, first of all, by calculating, we'll take the odds of passing or failing for students who attended lectures. 84 students attended lectures and passed versus 29 students who attended lectures but failed. You can calculate the odds from this, 84 divided by 29, which gives us a figure of 2.897. If this figure is above 1, this will basically mean that students who attended lectures will be more likely to pass than fail. Now we'll calculate the odds of passing or failing for students who didn't attend lectures. You can see this time it's 22 divided by 35, which gives you a value now of 0.629. So this is below 1. And this indicates that for students who didn't attend lectures, they were more likely to fail than pass. And you can use these two odds to calculate then the odds ratio. So the odds ratio will be the odds of passing or failing for students who attended versus the odds of passing or failing for students who didn't attend. We can feed these numbers into this calculation now, which gives us an odd ratio of 4.606. And what this means, how to interpret this, is that for any individual, attending lectures led to them being 4.6 times more likely to pass the exam. So you could report the Kramer's V effect size, but also report the odds ratio as well. And as I say, it just gives you a better indication of exactly how much more likely someone is to pass the exam if they attended lectures.